So, good evening, class. So, this is the sixth week of the Joy of Programming, and today's class will be mainly on recursion. If there are any questions regarding last week's class, feel free to ask, or in fact, any previous week's class, feel free to ask. Otherwise, I'll follow a sort of the week three's principle of I'll have a bunch of questions which are ready which are ready for you to solve, and I'll expect the answer from all of you. So if you have any, there are also additional questions behind me, and if you want to solve these questions, feel free to do so, and you can ask any questions if you want while you're doing it. So, well, the first question is this. So, what do you think the output of this function is? Since there are a few students in class, I guess we can go through a little bit about recursion just before the class. Sorry, for the introduction of the class. Like, personally, I feel the most important concept we learned in week 6 is recursion, because recursion is such a simple concept. Not easy, it's a simple concept, but it's very widely used in many places. In fact, there are languages which don't have for loops or while loops and expect you to solve everything using recursion. So that shows how powerful recursion can be. I must note that recursion is not always recommended, but it's a cool concept to know. So if you we can like quickly go through a question which involves recursion. Recursion is essentially a function which can possibly call itself, or rather, the essentially there are questions in which you can do a divide and conquer strategy, and there are questions in which you can solve a simpler question and expand it iteratively. So recursion tries to solve things like that. For example, if you want to find the sum of the numbers till n, you can use recursion for this, because instead of finding the sum till n, I can find the sum to a smaller question till n plus 1, and then I can add n to that. So we can write def sum till n. uh, Before any of you, some things I'll expect from this class is you will be expected to have known. Priya, could you mute? Do you have a question? Priya, do you have a question? Okay. So a very simple example is, so okay, there are mainly two main cases to writing a recursive function, and that is the base case and the iterative case, kind of like how proofs and some proofs kind of proof in math goes. So the base case in this case, if is n is less than or equal to 0 or 1, so if n is less than or equal to 0 1, because sum till n for if n is 0 or 1 is 1, is 0 or 1. Otherwise, we return n plus sum till n minus 1. And if you think about this, what this does is, step by step, it will calculate the previous sum, and therefore it will give us the total sum in the end. So we can quickly run this and see. So rent sum till pi. I'll put a breakpoint here just to show the steps. Okay, so right now the value of the input given is 5. You can see it here. Now as you step through, uh, just to clarify once again, right now I'm using VS Code and not Spider because I personally feel VS Code is just nicer. I can have like multiple tabs open and things like that, which I cannot do in Spider, or cannot do easily in Spider. And more importantly, I can write greater than or equal to and less than or equal to, and it will look nice. So that's my reasoning for using VS Code. Anyways, so right now the input of sum till is 5. It first checks this, and naturally it's false. This is so when it falls, because it's false, it will go to the 10th line. When it goes to the 10th line, it comes across sum till n minus 1. N minus 1 in this case is 4. So we'll go to read sum till 4. As you see now it's 4. And that will keep happening. And what essentially happens is it keeps adding things to a stack. This is what is happening behind this scenes essentially. Like as you call the sum till function, it keeps putting one more sum till inside the call stack. We'll see it happen. So now when you press, it added one more sum till in the call stack. That's because recursion is going on. Did that answer your question, Kesar? Yeah. So as I was saying, it will keep doing this until the value of n becomes less than or equal to 1. And once the value of n is less than or equal to 1, it will unwrap the call stack. Like each value of the things is one by one solved. So for example, right now the value of n is 3, and we know that sum till would have returned 3 also. Yeah, the sum till would have returned 3. As you go to the next one, for some reason it skipped 4, but I think that's because I clicked it too early, quickly. So, and at the end we'll get the output 15, which is exactly what we expect. So I hope the concept of recursion makes sense to you. But to properly understand recursion, you have to code things yourself. I hope you have written the code to calculate factorial yourself, because that is an excellent way to begin solving recursion. So I guess that's the first question we'll do actually. Write a function to calculate the factorial of a number. So how would this function look like? For those who have come late, I will once again explain. Oh, we'll essentially be solving random questions. Like will I'll help go through random questions like this, and if you want additional questions, you can always look up right above me, where I've written questions for you to try. Yeah, we can use a loop. I do not disagree, but I want you to write the factorial function using the recursive approach, because yeah, using the loop is a very valid way to solve it, but to properly understand recursion, you have to solve questions using recursion, right? So I would recommend you try to solve this using recursion once. Naturally, solving with loop is a valid solution. So if you want, you can quickly do that also. So the easiest way is, not easiest, but we solve a product equal to 1 for I in range n, 1 comma n. This is a valid solution. So print factorial of 5, that'll be 120. Why? Yeah, it's 120. But can you try this without using a loop? Can you do this using, well, recursion? So once again, because we're doing this using recursion, the first thing we need to do is look at the base case. What is the base case for the factorial? The base case is, well, when n is equal to, yeah, it can be when n is less than or equal to 0, but we don't usually define recursion. I mean, we don't usually define factorial for that case, right? So I would say the base case is n equal to 1. So yes, if Keshav, it should be if n is greater than 0.
No, no, sir. I have written half of the program. Can I send you the full program?
Yeah, sure.
Yeah.
Okay, so in case you see me write pass, that is so that I can have a function without any body inside. Otherwise, it'll give an error in the next line. I don't like that. Mm, mm. So to repeat, essentially there are two cases. Sorry, when you're writing a recursive function, you should consider the base case and the iterative case. The base case is what the initial value you know. So it's also called the first. Okay, doesn't matter. So it's all so in this for factorial, if n is equal to 0, return 1. if n is else, return n multiplied by factor of n minus. Yes, that is right. So I'll this is Keshav's solution, factorial of n minus 1. So if you run this, we get the correct answer, obviously, because this is how it should be. Now, one small thing we can do, like sometimes when you keep writing functions like this, the indentation just keeps going towards the left and towards the right and towards the right. So eventually you'll have like 5 layers of nesting, which is kind of ugly. So in this case, because we are returning in the first case of the if, it's implied that we don't need the else here, because there are only 2 cases, right? It goes to the base case and exits, and because it's exiting, we don't need the else, because yeah. So we can kind of clean up the function a little. So this would be the recursive solution. I hope that made sense. So that's a very basic question that we'll come across when you're doing recursion. So now let's look at the next question. Meanwhile, if people think that these questions are too easy, feel free to do the questions I've given on the top. Like when you realize what this function does, you'll realize this is the most complicated way you can write this function. But yeah. Okay, I can explain why we don't require else. So to those in YouTube, the question is essentially, why is it not necessary to write else here? So the main reason is, when you write if else, that means the thing does this or it does this, right? Now, if it's doing this, if it's doing the first part, it is leaving the function, which implies that it can't do this anyways. A return means it leaves the function. Remember, in an if else, we put the if and the else when we want the function to do this or do this. So if it's in the first part, it will do this, and it leaves the function. It doesn't have to do anything after that. It won't do anything after that. So because of that, it won't have to. It will not run this. If I put this here, the moment it reaches n is this, this is still doing the same thing, right? It will either do this or it will do this. It cannot do both at the same time. And this one just looks neater, in my opinion. That makes sense, Parni. Note that this is not always the case. Say the function looks like this. Def checking n. If n is equal to 0, t is equal to 4. If else t is equal So this is a really simple question, but in the end, you can see that here I can't put the return. I need this else here, because otherwise it will run this unnecessarily. The function is not returning here. The function is not stopping here. Because the function is not stopping here, it will run this also. We don't want it, which we do not want. Okay, so that's that thing. And so did anyone figure out what what this function does? So that's almost right, Kesha. The next okay, we'll go through this function iteratively. So where's debug? I forgot. So right now the input to this function is 2, 3, right? Because the value of x is 2 and this is the value of, so the if statement won't run. It will instead go to the return. Now when it goes to the return, what does it return? F of 2 minus 1 comma 3 plus 1. So the return is f of 1 comma 4. So we need to look at what 1 comma 4 does. And you can notice now that the call stack will go up by 1. It went up by 1. And now look, the value of x is 1, the value of y is 4. So it will, and because x is not less than 0, it will do it again. So this time it will return f of 1 minus 1 comma y plus 1, which is 5 in this case. So the next iteration will give us f of 0 comma 5. This time x is 0 and y is 5, therefore it will return y. And thus the output of this function will be 5, because it will now iteratively just keep returning 5. And that's what we get. The output is 5. Now what does that mean? So what is happening here? So imagine the input was like 6 instead. If it's 6, what will happen is first x will go down by 1, y will go up by 1. So the next this is the same thing as Control C, Control V. This is the same thing as 1 comma 7, and that is the same thing as 0 comma 8. I hope that made sense. So, and we know this will return 8 because the value of this thing is 0. What if this was 3 instead? If this is 3, if the value of x was 3, then what would have happened? If the value of x is 3, at the next step it will reduce the value of x by 1, and this will increase by 1, and it will output 9. So in short, this is almost the most complicated way to add two numbers. So yes, we can do a lot of weird things in recursion, including, yes, Bala, what is the question? Where's Bala? Ah, yeah. Oh, you did that accent. Okay, fine. So essentially, this is the most complicated function to sum two numbers. In fact, we can try it. Like, we can give 10, 20, and the output should be 30. the output is 30, because essentially what this function does is add two numbers. Like, at every point in time, we are subtracting one from the first and adding one to the next. So the sum of these two numbers will always remain constant for every iteration of the function. And because of that, this is the one of the most complicated way you can write a sum function. Okay, now let's look at the next question. If anyone have any, if you remember, if you have any questions, feel free to ask. I'm always, how is it iterating? I can answer that. I mean, what, it's not iterating in the sense of loops are iterating and things like that. I'm using iterating in the sense it goes from one to the next, to the next, to the next, and so on. So if I give this function, when I call f of 10 comma 20, it calls f of 9 comma 21 next, and after that it calls f of 8 comma 22, and so on. So there's always the next value it's going to go to. That's what I meant by iterating. Okay, so another way to think of what this function does, we know that at every, after calling the function, this, we are reducing x by 1 and increasing y by 1. That means the value of x plus y will always be constant. Like, if I call f of 20 comma 20, f of 10 comma 20, the value of x is 10, value of y is 20, so x plus y, that's 30. What does this function call? It calls f of 9 comma 21, and well, f of 9 plus 21 is still 30. So no matter where you are inside the call stack, it will always be, the sum will always be constant. And when does this function stop? This function stops when x is equal to 0. If x is equal to 0, that means the value of the output would be just y, because this sum has to be a constant, right? I think that didn't make that much sense. If I, okay, anyway, like, this is a slightly more weird question about recursion, so we'll just do the next one. The next question of recursion is not that difficult. In fact, next question, you don't need recursion to solve also, so there's that. So is there any more question? Like, yes, I see that you have asked how it's iterating. Maybe if you think a little bit for some time, it makes sense. So meanwhile, you can try solving the next question.
Sir, since it's a recursion, that's why it's repeating, like it's iterating.
Yeah, because every time I'm giving it an f, it is finding a next f, and that is what iterating means, right? Like, from one value, go to the next, go to the next, and so on.
Okay, sir, but how can I predict it's a recursion? Because
It's a recursion because it's calling the same function. Like, f is calling f, so that's a recursion.
okay, okay, sir, I got it. Thank
Yeah,
you.
yeah, no issues. Okay, so for the next question, the hint I can give is there is a method for finding square root using repeated division. Okay, so it is called, is it called a Newton's method for square root? We don't need that. We don't need that. Where? So Newton's method is in general, they have made it. It can be used for much more complicated things also. But the Newton's method for square root. Okay, I will just explain it. Essentially, what Newton's method for square root does, yeah, that the screen should be visible. I am sharing my screen. I do not think I can do anything more than this on my side. If you have any more issues about not seeing the screen, please do tell. So I will explain the Newton's method for finding square root. Essentially, if I have a number, so Newton's method. So essentially, Newton's method says if I have a guess for a square root, I can find a better guess with just addition and division. So let's say we are finding the square root of 3, and I'm guessing this. And I'm guessing the square root is, well, close to 1.5. So I'll write guess is equal to 1.5. What Newton's method says is I must first, I'll find a temporary value called, well, I'll just call it temp. Temp is equal to num divided by guess. Newton's method says that a better guess is the average of guess and temp. So just to show it out, we can make this a follow for in range 20. No, we can just put 5. So you can see we get 1.73205, which is actually very close to 3. We can just check it here. Like this is it's surprisingly close already. So in fact, if you increase the range, did it reach its? Oh, okay, so that has reached the floating point, the limit of Python's floating point accuracy. So that was unfortunate, but yeah. So if I remember correctly, this is like this reaches the value really quickly. Anyways, so my question to you is, yes, can you code this anyway, but preferably not using the same method? Remember, there are always like probably 4 other solutions to every question you're solving. So I always recommend that you should try your own method to solve these questions. And this works for anything, so we can print guess here. And let's start with 100. We know that the final solution is supposed to be 10, and we can see slowly how the bad guess eventually becomes a good enough guess. So it starts with 1.5, then it goes to 34, which is really wrong. Okay, there's oh yeah, oh eh, the square of guess is, yeah, okay. So you can see right now, I started with an awful guess, but within 5 iterations, we got very close to the actual value. And after that, it essentially reached 10. So can you try to code this in a recursive manner? Okay, I am sorry. I kind of missed out one thing I wanted to say. So before you do this, there is another concept I wanted to introduce. View word wrap. So sometimes you don't want to always pop sometimes you don't always want to give every input to the function. I've mentioned this earlier. Essentially, in the value in the print, we usually only give the first value. But remember, there are all these different other values, which all these different other things you can also add. So I can write end is equal to 3 and it will end with 3, right? But I don't always have to do this, right? So it is these are called default parameters, and you well I don't remember explaining explicitly how to write default parameters. So writing default parameters in Python is incredibly simple. All you have to do is, well, start writing a function. We'll say function print. I have the parameter. I am Yeah, all you have to do is just put an equal to and give a value to the parameter. So for in this case, it will be hello, is the voice not audible? Oh, can you let me check my oh, I'm using the right settings. Okay, thank you for clarifying. Okay, not input so I here have just made a small my print function. So if I give some value like hello, it will print that. Yeah, it printed hello. But say I don't give anything to the function, it will print you did not input a value, because if I give hello, it will by default give it to s. If I don't give hello, it will say that s is equal to this value. So you can see this might be useful in several functions. So for example, in the print statement, it's exceedingly useful because you don't want to always give the values of every parameters. You can see how many parameters there are. There's separation, there is end, there's file, there's flush, and things like that. So we don't always want to write every parameter of a function. So default parameters are very useful. So about default parameters. So once again, many people come just now. If you have any questions regarding last week's online lectures and things like that, feel free to ask. And if you're bored with the questions I've given you here, feel free to do the questions above. I feel like those are slightly harder than the questions which I've given. So in the end, the only way to get good at Python is to code it yourself. So I highly encourage you to have Python open and code the questions, code the solutions.
So can you please explain me the programming assignment of week 5?
Week 5, give me a second. Which programming assignment?
First and second.
Oh, I didn't do this one. Okay. You're given a. Oh, because the output is here. So because the due date is over, I can easily show it. Okay. So yeah. So the question says you're given a string s and you have to write a function count letters which will contain a dictionary containing the letters in s as keys, right? So we'll start with what all they have given. So we have def count letters and the input is s, a string. The output should be a dictionary. So we'll define a dictionary. Dictionary is equal to. Now you must fill this dictionary with the letters in the string. How do we get the letters in the string? The easiest way to get the letters in the string is, because the string is an iterator, we can do for letter in s, and that gives us each of the letters in s. Just to check, we'll print the letter and we'll see. Print letter. So count letters of hello there. Well, let's run, and the expected output from this is HELLOTHERE exclamation mark, and that's what we get. So it's so far we have not made any careless mistakes. So now we need to fill the dictionaries with the elements of this fill the dictionary with these letters. So first, there are two cases. Either the letter is already in the dictionary or it's not in the dictionary. So how do we check that? Well, we check if letter in dictionary. If the letter is in dictionary, that means we have to increase its count by 1. That means this is the second time or third time we are seeing that letter. So we will take dictionary of letter and we'll increase it by 1. If the letter is not in dictionary, we must set it to 1. Else dictionary letter is equal to 1. And at the end, we just return dictionary. So we can check and print. And if you see, the results are expected. There are 3 letter E's, there's 1 letter L, there's 1 letter O, there's 1 space, 1 T, 1 H, and 1 R, and 1 exclamation mark. So that is, oh, we can use their input also, and we should get this one. And yes, we do get their result. I hope the steps I did made sense. I must clarify that a lot of this comes from practice, and if my speed was scary, it's only because I've been doing this for years. It's fine if it takes I would recommend that you try this out yourself, and it's fine if it takes a lot of time, but in the end that you should feel satisfied about solving this yourself. I hope the steps for the first question made sense. Like, some of the things about how I wrote this is because of practice. In a little, maybe if I might have done this instead earlier. If so, it's more intuitive to think of the first case, this case first, right? Like, if you come across a letter you have not seen before, this is what you must do. If you're otherwise, you must take that letter and increase it by 1. Okay, I'll see this next question also. So I hope the first question made sense. If there are any questions, feel free to ask again. Yeah, like,
So
please
without
interrupt
getting
me.
like
Yeah. Sorry, I interrupted you. Could you repeat?
how the given output is added in the dictionary and it's converted in key and values.
What?
Sir, I have given the output like the joy of computing. How it's added in dictionary and it's converted in like keys and values.
You're asking how this output is being generated?
Yes, sir.
Oh, so okay. In general, most of the things in Python have a default representation. So as in, how, like, computers see all of this as ones and zeros. We don't see it as ones and zeros. We need a way for we need to look at the thing and be able to understand what it's saying. So most of the things in Python have a representation. In fact, if you look at it, if I say dict is equal to this, there are extra functions called /rep. This function tells how the function is represented. So if I run this, Control S, this is the representation of the function, or else as in the human readable representation. So I'll specifically read that. Human readable representation of the class. Let's not think of what a class is. It's something which is there, essentially it stores data. everything in Python essentially stores data, and the wrapper gives us the representation. So this what they have given here is the default representation of a dictionary. If you want, you can I don't recommend it, but technically you can change this also. For example, like if I remember correctly. Oh wait, no. So I'm going on a tangent. We don't need to care about. We don't need to look at that. But essentially, this is the default representation of a function. For other things are, if you have a set, its default representation is like this set. If you have a slightly, what's the most complicated, a range 1 comma 2 comma 9, its representation is range 1 2 comma 9. So you're not expected to print it like this. This is the default representation of a dictionary. If you're asking how to get these values inside, like saying T is 1, H is 1, E is 1, and all of those, that is based on this function. And I think this function made sense to you, right?
So can you explain this function?
Okay, I can explain this function. So let's look at the question again. The question says we are given a string S. Naturally, that means the input of this function is S. We need to write a function which will return a dictionary containing letters. So we need to return a dictionary. So I defined a empty dictionary first. There's no value inside this dictionary right now. Now we have to go through every letter in S. That's what they want. They want a dictionary containing the letters in S as keys. So I need to go through the letters of S. The easiest way to go through the letters of S is because a string is an iterator, a string is a collection of letters, right? It's a collection. So we can use this syntax to go through the letters of the string. We can see the letter print f the letter I am looking at right now is letter. And if I run this, this thing makes sense. So as it goes, it's looking letter by letter. As the for loop goes, it's looking letter by letter. Now there are two cases. Either the letter is already in the dictionary, or the letter is not in the dictionary. If the letter is not in the dictionary, that means we are coming across a new letter, and because it's a new letter, we have only seen it one time so far. That is right now. So when I see this T here, that means I've seen this letter exactly one time so far, and that's the T. So if that means if the letter is not inside the dictionary, I must set the dictionary to that. We must set it to 1. Otherwise, if the letter is inside the dictionary, I must increase the value. Did this part make sense? I guess this is the most confusing part. So let's just print the dictionary also. The dictionary looks like dictionary. And when I run this, okay, So this will get really ugly very quickly. So I'll just put the joy instead. No, I want a letter which repeats. The very sophisticated words. So the first letter of the string is T, and I've not yet put T inside the dictionary yet. I said yet twice. Okay, sorry. So at this point, dictionary still is empty. When I then I put so the thing goes inside this part. If letter is in, it should be in there, but yeah, if not letter in dictionary, this statement checks if the key is in dictionary and not value. That is correct, Ratnakumari. Yeah. Essentially, here I'm checking if this letter is a key in the dictionary. If I accidentally said value, I'm sorry. Yeah, I apologize for that. I meant key. If so, here this checks if letter is a key in the dictionary. If the letter is not a key in the dictionary, I will set it to 1, which makes sense because at this time I've seen exactly one of those letters. So that's what's happening. When I'm looking at the next letter, there's only one thing in the dictionary, and that's the T. And then when I go to E, I've seen a T and an H, and so on. So I hope that made sense. In case I accidentally said value in key, if I accidentally said value instead of key, please forgive me. I meant to say key instead. Every time I was talking about letter, I meant key and not value. The value of the key is the count, and the key is, well, the letter.
Sir, I have understood this if and else condition, but I'm not getting how these converted in keys and values and added to the dictionaries.
So, okay,
Like
let's look. Hmm?
how it how I come to know that this value is key and then this value is
Okay,
going to
so
store in value.
I will quickly explain a bit about dictionaries, I guess. So, a dictionary is a very useful concept in Python. A dictionary essentially is a pair of keys and values. So I can do a diction. Okay, so what this is a dictionary. This dictionary has 4 keys. The keys are name, age, job, and profession. The 4 keys have 4 values. The name, the the value corresponding to name is Naveen. The value corresponding to age is 25. The value corresponding to job is this, and the value corresponding to profession is, well, this. That means if I want to look at these values, I can just call it like this. And it prints Naveen because that's what the name is. If I write age here instead, it will print 25 because that is what that value is. So in lists, A is equal to 2, 7, 3, 6, okay, random numbers. To access each element of the list, we did A of 0, A of 3, and so on. Similarly, to access the values of the dictionary, you do A of key. Sorry, dictionary of key. Obviously, it has to be the actual name of the key and not just key, right? So, what do you think will happen if I print this dict? Can we consider key inside a dictionary as constant variable? The keys inside dictionaries are constants, not constant variables. Like for example, in this case, the keys inside dictionary are the letters themselves, the letters A, B, T, H, and so on. Those are not variables. Can we get any? So getting the key from the value is not, there's no nice way to do it, because technically that's not what a dictionary is used for. You there are ways you can get a key from the value, but it's not general, because I'll obviously this will happen. So this is how the dictionary is represented, right? The thing is, the keys in a dictionary have to be unique. If I write name is Naveen now, it changes the dictionary. And now my name is not capital N Naveen, it is small n Naveen. Because when it reads this, it just overrides the previous value. Because keys in a dictionary are unique. There's only one possible key. For one value of a key, there's only one value associated with it. Keys in a dictionary are unique. This is a very important point. Okay. However, I don't need this line. Full name. Keys in a dictionary are unique, but values in a dictionary need not be unique. Because the values in a dictionary are not unique, your question does not really work out. Because if I ask for Naveen, should I get full name or name now? That doesn't make sense, right? For one value, I can have multiple keys. So I'll repeat this important thing again. In dictionaries, the keys are unique. Essentially, think of a locker. A dictionary is a locker, and keys are the keys. So you have a bunch of lockers, and each of the lockers have a small lock, and with one key you can only open one of those locks, and you can open it and get its value and be like, oh wow, the value of this is Naveen. Oh wow, the value of this is eating food, and then you can close the key and let it go. But different lockers can have the same content. Like one content can have Naveen, another content can have Naveen. That's fine. The values can repeat, but keys cannot repeat, because keys repeating does not make sense. So one logical way to think of a dictionary is like a bunch of lockers, and you have keys to open each of them. So what if you extend that metaphor? If you extend that metaphor to this question, what are we looking at? So when we come across a new letter, there are two cases. Either the lock is made and we know there is some number associated with that letter, or we have to say, okay, we need a new lock and key for this letter. So in the first case, I mean when if you need a new lock, if you need a new locker, you will set a dictionary value like this. This is how we initialize a dictionary. But say you want to change the dictionary, then you do it the same way. You do it like this: dictionary of a new key is equal to a new value. So this is the way you initialize a dictionary, and this is how you give a new value or change an old value of a dictionary. So when I do dictionary a new key, what I'm doing is I'm asking for a new lock and putting the value, a new value into it. I hope that made sense. I think I shouted too much. My throat hurts already. Okay. So that is the idea of dictionary. I hope that made more sense than before. I sincerely think the idea of a dictionary being a key and lock is kind of a nice way to think about it. So, well, that's about this. So, as I said, there are two cases. Can we modify a key in a dictionary? Yes, you can. That's what I'm doing here. So what I'm doing here is I'm taking the key and opening that lock, getting the value. If I can write this explicitly. Control C. So what I'm doing, I'm taking the key, getting the value, I'm adding 1. And then I'm saying the new value inside the lock is, well, this value. So this is how I'm modifying a key in a dictionary. This question has two parts: adding new keys to the dictionary and modifying the old keys. No, you cannot change the name of the key unless you just make a new key. There is a wait, let me check one thing. Dictionary of Dob is equal to none. Print dictionary. Yeah, you can't do that. Can you use delete? Yeah, you have to use the delete function to remove a key from a dictionary. Otherwise, from keys get pop, this pop. Yeah, you can use this also. So if you want to remove, so the best way to modify a key name is to like add the key and just delete the old one. So the way to delete a key is using the pop function. And you can add, yeah, I told you how to add a key. So like once again, control T, dictionary methods in, will always recommend that you go read these once. Like every methods in Python, every data types in Python, like strings, lists, set, and dictionaries, they all have methods associated with them. So say you want all the values of a, say you want all the keys of the dictionary, then you can just use this function dot key. Can't do that. See, so it prints all the keys. The keys are name, age, profession, full name, and a new key. So if you're when you're going through this, I would really recommend you go read all of these. Okay. Anyways, so I hope that clarified the first question. Now let's look at the second question. Okay, so once again from the function, let's what's it in unique key. So we are writing a function def unique key, and the input of the function is a list. There are so many ways to do this. There are a few ways to do this, and I'm not sure which is the easiest one. So since this is a since this is last week's assignment, which talked about dictionaries, I think we'll use dictionaries to solve this. In fact, we can use things of the previous we can use most of the previous code for this. So control C. Okay. Okay. So okay, well, let me read Parneet's answer. M is equal to, that's a very simple and excellent answer. So it does exactly what the question asks. Like there are two cases. Either the element is inside the list, inside the new list, or it's not. If it is inside the new list, that means your Parneet, that there's a small mistake in that, and think if you I think you can notice it eventually. What if a list has what if the list input is 333? Do you see how that will break your function? I mean, not break, will give a wrong solution to yours. Okay, I will continue explaining my solution using the dictionary. So once again, there are two cases. Either the element is inside dictionary or it's not inside dictionary. If it's inside dictionary, I'll increase it by 1. If it's not inside dictionary, I'll set it to 1. Now, I have to create a list from the dictionary. So I can use a for loop for this. So M is equal to an empty list for key in dictionary if dictionary of key is equal to 1. Just to clarify once again, this is a long equal to, it's a double equal to. Because of my fonts, it looks like this. Okay, anyways. So if dictionary of key is equal to 1, I'll append it. M dot append key. Then I sets off to. Oh yeah, I can just do that, right? Yeah. M dot sort return M. So this is one easy way you can solve it. Parni, did you understand why your function won't work? It works in most of the cases, but there can be tricky inputs. Okay, good. Okay, fine. And yeah, so this is one way to solve it. I hope this method made sense. The most of the method here just uses the previous function, because as programmers it's okay to be lazy. Okay, so we can just test print unique key. Control C. And the output should be 1567, and the output is 1567. We can make this slightly nicer. Essentially, instead of putting 1 and this thing, we can put true and false, because why do you want to unnecessarily calculate values? So essentially, if I'm coming across a key for the first time, I'll set it to true. Otherwise, I'll set it to false. And because it gives us true and false immediately, I can just write if dictionary of key, because dictionary of key will give me true or false. So this will also give the same value. This might seem a little complicated at first, but you might get used. You might understand it in a while. So while I was explaining this, did anyone solve the questions above? Do I have any solutions for them? Okay. Otherwise, we'll just continue to the third. So, Kesh, do you want me to go through the third question also? Oh, that's
Yes, sir.
okay. So let's go through the thing again. Oh. Okay, so once again, oh, they're not even asking. Okay, so first we are given a list L, and you must find the first prime number in that list. So we'll just take this as the input. A is equal to list. Okay, so naturally the first thing we need is a function to identify if something is prime or not. It should be a function because functions are nice. Functions are nice. So we just write def is prime, and the input of the function is n. If n is less than or equal to 1, okay, let me look at Prachi's solution. For I in L, a is equal to 0 if j in range 1 to I, if I mod j is, yeah, that will work, right? I'll just copy your code and paste it. This L is equal to a. For I in L, I is equal to, change this to L. Can I run this? Yeah, makes sense. So if I put the answer should be 3, and it's 3. Yeah, Prachi's answer works. It's a very intuitive answer. Essentially, I personally like functions because I told this a little while ago. I don't like it nesting so deeply. So what I would have done is made this entire part a function. So if n is less than this, for I in range from 2 to n, if I mod 2, if n mod I is equal to 0, return false. Otherwise, return true. And if I do things like that, then this will be replaced with if is prime of I, and it should give the same result. Not pass, it's return false. Yeah, like Prachi's solution works, but I just have given a solution which uses what's that called, functions instead. Did that make sense? Okay, so that concludes with, like, is there any other way to do it? There's definitely other ways to do it. It just depends on how creative you are. Like, we can easily optimize this because you don't need to check the last values, and this will make it faster. You can use dictionaries also to make it faster, because for this input, I know 10 is not a prime. I've already calculated at least once. So because I've calculated it once, there's no point of me calculating it again and again. So we can use dictionaries to make this faster. So I can write dictionary is equal to empty. And the first thing I'll check is if n in dictionary, return dictionary of n. Because if I've already calculated this value once, I shouldn't do anything else. I should just return the value in dictionary. Otherwise, I have to calculate it. So if n is less than or equal to 0, I'll set that dictionary of n is equal to false. Likewise here, dictionary of n is equal to false. Dictionary of n is equal to true. So this is a way to make it faster. What happens is, because I've put things in a dictionary, when I come across the next values, I don't have to do the entire checking for prime again. I already know that this that prime that what's that thing called, that's not a prime number. I already know that's not a prime number because I've already calculated it once. So there are other ways to do it. Like right now I'm blanking on other more creative methods. Like there could be a property of a prime number which you can use to solve this, I guess, but I'm not able to think of it right now. But Prachi's solution is the simpler solution for this. Do you want me to go through it again? Like okay, fine. I'll just quickly show that I'm can I wait, what if I control C? Okay, so I've got the old function back and now I have both. So imagine the dictionary was 1000 multiplied by 100 plus that will work, right? Okay, so if I have 1000 multiplied by 100 in the beginning of the list, and only then and even after that I have 3 here, then my function will be kind of fast. It will just compare it with the old one. It's still fast. Why is it fast? Obviously, it's divisible by 2. Obviously, this is fast. We'll just quickly do Python. Just give a massive 103 multiplied by to be a prime is 1000, no, 1007. That doesn't sound like a prime. Yeah, maybe this will take more time. Oh, I need a really big prime number. Big prime Okay, that's too big. Give me 7727. 7883. This should be slow. Okay, it's actually slow. Yeah, you saw it explicitly take so much time, right? So, uh, but on the other hand, if I had used the dictionary approach, it will be slightly faster. The dictionary approach is once again like just as fast as before, but the other approach was slightly slow because it had to, even though we had calculated that this is a prime number, it had to calculate that again like 1,000 times. Someone raised their hand. Okay, if you have any question, feel free to interrupt. What's an array difference between an array dictionary? So, okay, in Python it's called a list, by the way. Once again, I'm sorry if I accidentally called it an array. Parneet, I'll explain that in a short while. Okay, an array is essentially, sorry, a list is essentially a list of numbers. So I have a of, it's defined like this. So I can have just list of random things. So a of, the first value of a is 3, second value of a is 6, third value of a is 87. A dictionary, on the other hand, is not a list of, it's not a list, it's a pattern of, it's a bunch of keys and values. There's a key and there's a corresponding value. So even though the syntax is similar, that I do a of 0 and dictionary of name, I'm essentially doing something slightly different. A of 0 is taking the first value of a. Dictionary of name is getting the name from dictionary. You can think of lists as a dictionary whose keys are numbers, but that is the most complicated way to think of a list. A list is just as simple as you think it is. It's just a collection of things, an ordered collection of things. Sorry, an enumerated collection of things. That is, you identify the element of the list by the number. So 9 is the fifth element, which will be index 4. So that is the main difference between a list and a dictionary. Now back to Purpaneet's question. So the only issue with this function is it can accidentally do calculations again unnecessarily. So say in this case, for control x, l is equal to, okay, so for this we have l is equal to 1, 10, 10, 10, 10, 10, 20, 3, 4 and so on. So when I'm doing this function, I'm going through every element of the list, and the first element of the list is 1, the next element of the list is 10, so I'll check if it's 10 is a prime, and 10 is not a prime. So okay, that's cool, so I'll just continue, and I come across 10 again, and then I check if 10 is a prime again using this function. So I'm going to check if 10 is prime like 4 times in this. And note that this function is not slow, but it is calculations. It has to calculate for a while. So because 10 is a small number, Python can do this really quickly. But here I am going through so many numbers. So if I'm checking for 201, if I'm checking a big number, this for loop can be potentially very large. So in the end, this function has to do a bit of calculations every time to check if a number is prime or not. What my new function is doing is I am storing the values after I've calculated it. Because I've stored the value, I don't have to calculate it again because I've stored the value. It's like for this, when I check for 10, I've stored the value of 10 inside the dictionary, and because of that, I don't have to do all the calculations again to check if it's a prime. I can just look at the dictionary, ask it, have you seen 10? And it'll be like, yes, I've seen 10, it's not a prime, and I don't have to do any of those calculations again. So that is the idea behind using a dictionary like this. This is a very fun, interesting concept called memoization. Memoization. Yeah. It's such an important topic that people gave it a name. Essentially, it's just a way to make functions faster. I hope it made better sense this time. Praneeth? Oh, I put this huge prime number because Python was fast enough to do it very quickly otherwise. If I gave it a small prime number like maybe 783, it would probably not take this much time. Like I gave oh, by the way, this is not a prime number. This is composite number. This number has a prime factorization, which is 7727 multiplied by 7883. So this is not a prime number. So to check if this is a prime number or not, this function has to go all the way until 7000 and do a lot of calculations. Yeah, I mean, every numbers are products of primes, right? Because it's a product of prime, it's not a prime number. I gave this just to show that this function can be slow at times. So if I put this again, Control C, Control V, plus, I'll put an extra 0 to emphasize how slow it is. I start running and we have not gotten the answer yet. My computer started making noise. I can hear the computer trying to compute the thing now. Okay. Yeah, so, and in the end, it still gave the same answer. So my point was, this is a big number. So it took time to find the factors. And I didn't expect my computer to make noise for this. Okay. Anyways. Okay. So yeah, this concept is called memoization and it just makes things faster. So if I do my new prime, it will take just be super fast. So I think we have gone through all of these questions, and okay, we'll go through the my square root function again. Did anyone solve this? Okay, so if I were to solve this, I will first start giving a default function, a default argument, and let's say the default argument is 1. So I'll first, the base case is if the guess is already good enough. So if guess multiplied by guess is absolute function, absolute function, minus num is less than precision, return guess. Otherwise, I do the things I said earlier. Where did it go? Yeah, this, the Newton's method. Which programming assignments? The one in the Swime portal, or the programming assignments, the programming questions I'm doing right now? I do not know where the programming assignments are made from, actually. I mean, the programming assignments in the Swime portal, I do not know where that's from. I just know, yeah. So, and now I'll just make the temporary variable temp is equal to num by guess. And now the better guess is this. So my square root of num precision, and the new guess is temp plus guess by 2. So this is a recursive way of doing Newton's method. So if my square root of 3 and I want a precision of 0.01, I need to put a print statement. Print. So there, that's the value. We can even check. There's no nice way to do it actually. So square root 3 is equal to control X, control B, print F. Okay. Yeah. So as you see, this is not a perfect square root, because when you take the square of this, we get 3.003, but that's within the precision that we want. So because of that, the program stopped. If you gave it further precision, it will try harder, and this is a better solution, and it gives us a value within the precision we want. So this is how you can use, this is the other ways you can use recursive functions. So can you try the next question? Has anyone tried the questions I've given above, like the first question here? Okay. So does anyone have an idea how to solve this? The check palindrome function? I hope everyone knows what the palindrome is. Okay, so let's do it. So the easiest way is, okay, so the base case is the empty string. If s is equal to this, return true. There's another base case for this. S can be a string of length 1, which is also a palindrome. If len of s is equal to 1, return true. Now we'll check the first and last letter of the string. If they are not equal, it's not a palindrome. So if s of 0 is not equal to s of -1, return false. Otherwise, we return, we just look at the inner values. So return check palindrome of s from 1 to -2. This is -1. -1. So do you see how this will also give us the same solution? Do you want me to explain this? So we can. I hope this solution made sense. Oh, I had forgotten. We are like halfway through the course. I wanted to ask for feedback. Okay, I'll do that next class. So, so that is this question, and well, we'll go to the next question now. So the question is, what's the output of this function? Sorry, I changed. So does anyone have an idea how to solve this? Like one thing you can try, you can like cop like use some text extractor to get the code and put it on your PC and try. That's perfectly fine. Okay, so at the risk of spoiling the answer, this function calculates the exponent. So the idea is, I'll write comments to make things more obvious. If n is negative, we take the exponent of 1 by a instead. If n is 0, the exponent is always 1. If n is 1, the we get a. So in this case, there are two base cases. This is also a recursive step if you think about it. Okay, now I call the function again, but with a half power instead. Okay, so when I'm doing exponent of 3 comma 4, the first step will take me to exponent of 3 comma 2. If once I get exponent of 3 comma 2, I can do that multiplied by itself to get the new thing. So it depends if n is even or odd. If n is even, I just multiply it by itself. If n is odd, I multiply by itself and multiply by another a after that. Did that make sense? So this works for everything. So if I put a negative number here, I'll get 1 by 181. 1 by 81. If I put 5 and 3, we'll get 125. The cool thing about this step is it does calculations in a smarter way, and because it does calculations in a smarter way, that you do much fewer multiplications this way than if you traditionally just use a for loop. So sometimes recursion can help out a bit, but then again, you can always code this in a way which does not require recursion. Recursion in the end is a tool, and it's up to you whether you want to use it or not. So this is a really simple question, so we can try that also. In fact, I'll leave this as an assignment, and we like wind down the class now. If there are any questions, feel free to ask. And I'll be here till 8 o'clock. I will like slowly answer this in the next 5 minutes, but not going to rush it. So if there are any recommendations how I can improve my class, feel free to suggest it in the chat, or you can say it if you want. But if you're saying it, I'll prefer if you say it after the class, because I don't want that to be recorded. So yeah. But yeah, if you have any suggestions on how I can improve in teaching the classes, please feel free to say. Like next week, I think I will upload a Google form where you can like put all your complaints about me and things like that. Because in the end, just like programming, even teaching requires practice. So I'll start doing this. Oh, that's actually very nice. That's nice to know. Thank you, Ratnakumari, for that compliment. Not sure how to do this with recursion. This. Why am I overcomplicating it? Okay, so the class is officially over. I am stopping the recording.